Cluster B, Yoshi, I will start from the explanation of the freezer. And then next, chemical filtration, and then go to the DNA extraction lab, cell culture room, heat lab 3-4, and heat lab 2-1, molecular lab, and routine analysis. Okay? That's zero. Okay? Number one, it's relatively wide, bigger than other rooms. You already visited other rooms and then quite small, right? But this room has enough space because since the deep freezers are the heat generating machines. So if you put in a small space, easy to become the room temperature become very high, and they give the heat pressure to your freezers, and then have to run so much, so hard, then easy to be broken. So to avoid that, we use the relatively wide space, and then we install the AC, and then these two AC, each one have a capacity to enough cool down this space. Okay, not half capacity. Okay, this one can cover this entire room, but we set the timer. Then every 6 hours change the operation. So while this one is functioning now, that one is taking rest. And then after 6 hours, that one will automatically start running. So at least 6 hours, every 6 hours, the machine can take a rest. So the machine will not become overloaded. Okay? That's the one, the uniqueness. Second uniqueness is that one, the backup system. So in case the electricity shutdown occur, we can keep at least 2 to 3 days. Okay? So using the 12 batteries. Okay? So even the continuous the electricity cut-off occur, we can protect our precious samples and also pathogens. Okay? And then also we have the locking system. So we haven't put the padlock. We already prepared that like this, so that anytime we can start the padlock system, so that we can securely store our materials. Okay, and then all this type, the chest type freezer have excuse me. Like this inventory rack. So you can see that CH3-3 means channel 3. This machine is channel 3. And then 3 is 1, 2, 3, 4, 5, 6, 7. Okay, and then level is written here. So if you record channel 3-3-1 means here. Okay, so you can pinpoint where the sample is.
Wow.
No? So this one locally made in Nairobi. I requested Ascari to make it. So these are the extra. Okay. This is made in Kenya. Okay. Okay. And then some samples are not the cryovial type, but longer or bigger, or the centrifuge tube type sample. So in that case, we use this upright type freezer. Okay? Maybe you can have this side. Okay? In case those samples are those shaped like this, it cannot fit to the cryovial box. Right? So that's why we use this, the drawer type. So this drawer also have a number. Right? Same way. Okay? So just channel 4 is this machine, and the 2 is level 1, level 2. Level started from 1, 2, 3, 4 like that. Okay? So that's the numbering system. Okay? Okay, those are the uniqueness of this the freezer. Okay, so if you haven't done such system, maybe you can think about it. Okay. The weighing machine and also the pH meter like that. So duplicate, triplicate, you know, because they keep their own machines. So we need to buy so many similar machines, but we centralize so that we can use the same machine for the different the research groups. So we don't need to spend so much money to buy the equipment, right? Then, but the laboratory managing committee member, the one who maintain the good condition of the equipment. Okay, so we have a double distilled water or the ultra pure water, and then also the single distilled water, the millicube. Okay, okay. This is a millicube, and then this machine can produce the single distilled water and then double distilled water. Okay. Okay. Then before the applying the tap water to millicube machine, we pass the can you see here the filtration cartridge.
Yeah.
Because tap water is not clean.
Yeah.
No? Sometimes it's brownish or reddish water come. So if directly connect to this machine, the cartridge will be immediately damaged. That's why this same one is here. Same one. This one is for the ice maker, but another one for the liquid. Okay. Can you see? Okay. For clean items, okay, and then also the pH meter, the weighing machine, like that. Okay. Right. Next we go. Okay. One more thing I forgot to tell you. Maybe difficult to see, but this one is AVR. You know, your country also sometimes facing the irregularity of the electricity, right?
Yeah.
So you use the AVS, automatic
Stabilizer.
voltage switcher,
Yeah.
and then automatic voltage regulator (AVR), and also the UPS. Those three machines you use. Also do you also this is AVS, huh? So since autoclave should be complete the 15 minutes or 20 minutes at 121 degrees Celsius. So if the sudden stop during that 15 minutes or 20 minutes happen, the sterilization become incomplete, isn't it? So it's quite dangerous. That's why to avoid that, we connect the AVR, so that AVR try to maintain the stable voltage, so that if you use the AVS, of course AVS can protect the machine, but anyway machine will stop the running. Okay, so means the sterilization will be ended as incomplete condition. No, it's not good. That's why we use the AVR instead of AVS. Okay, ice making even sometimes it stop. It's still okay, but the autoclaving should never be interrupted. That's why we use this. Okay. So how about the UPS? In which machine should you use? Oh yeah, computer related one. For example, sequencing or PCR. No? Those relatively long period you run and they should not be interrupted by the fluctuation or electricity cut. In that case, you should use the UPS. Okay? Okay. Okay, let's go. Okay, so this is a DNA extraction room. Okay. Here, not much the special equipment. The people are working on the snails. Maybe you can see the snail. You can enter. Okay. あれ Oh, very good security. They helped. They are collecting the snail, the how to say, intermediate host of the Schistosomiasis, no? Schistosoma mansonica.
Yeah.
Mansonica. Okay, so they are checking the size and also detecting the presence of Schistosoma parasite, like that. Okay, so this is this room. Okay.
Only?
Eh?
Only schistosomiasis.
Schistosomiasis and then trypanosomiasis.
Trypanosomiasis.
Trypanosoma, the tsetse fly is the vector, right? So the after the identification of the tsetse fly, the keeping the sample in a minus 30-degree freezer. Okay. Then Dr. Kambe is detecting the what type of trypanosoma parasite exists. Okay. Let's go. Before we enter the cell culture room, you may wonder what's this corridor? No? This corridor for the keeping of the you can come the CO2 gas. Usually, many laboratories put the CO2 gas inside of the laboratory, isn't it? Yes. Okay. I think for the cell culture room it's okay, but for the P2 laboratory, which the field sample, clinical sample, or pathogen handling laboratory, there's a possibility of the contamination of the cylinder. So instead of putting the cylinder inside the laboratory, we put here and then here. Using the pipeline, we connect where? That one. Pass and then connect to the CO2 incubator. So there's no need to bring in, taking out of the heavy weight the cylinder, but straightforward. Take out and bring in. Okay, so that's why we are keeping the cylinder, CO2 gas cylinder here. Okay, and then so please enter from the cell culture. To have a special door. Okay, you can enter. Okay, everybody enter.
Continuous.
Okay.
Let's go.
Okay, and so this room is a cell culture room. So we have two crane benches. So mainly two functions. One is for cell culture, cell passage, or preparation of cells for the virus inoculation, like that. And then the other function is, you can see, master mix preparation for PCR. So you already learned yesterday from Betty that for the PCR work, you should have 3 different rooms. No? First one is a master mix, clean room. Then the second one is a mixture of the master mix and then your sample DNA or RNA, and then run the PCR, right? And the third one is after the PCR, you run the gel electrophoresis. So you should not open the PCR-ended tubes in other rooms because it may contaminate with full of PCR product. So only allowed to open inside of the gel electrophoresis lab. Okay, so that you can avoid the contamination. Okay, so the preparation of master mix we do here. Okay, so then as you know, cell culture we usually use the mammalian cell culture. We use the 37 degree Celsius, and also we are doing the arbovirus research. Arbovirus means arthropod-borne virus, so the insect or other tiny creature, okay, like ticks. Okay, so in that case we use the 28 degrees Celsius, relatively low temperature, the incubator. Okay, and also we have a 37 degrees Celsius, but the 5% CO2 gas. Okay, so in case of open culture system, like a plate or the the blood cell derived cell line, they need the how to say neutral condition of the medium. So from the even the before cell number grow. So in that case, we started to culture with 5% CO2. Okay. Okay. So now we go out. Okay. Now the two Japanese students and one Kenyan student doing their research work. Okay, they are from Yamaguchi University in Japan. Okay, so this room is the P2 laboratory 3 and 4, but we don't have a wall to separate two. So this room is for the microbiology and then the virology. Okay, so we have three biosafety cabinets. Okay, then we have two autoclave machines. So already Gabriel and Martha explained to you that in P3 laboratory, also we have two autoclave machines, right? So same thing. No? So there, if you have two autoclave machines, at least one may be available. Even someone is using one, still the other one you can use when you finish your work. Okay? If you have only one, if somebody is using, you have to wait until that autoclaving finish. So to minimize the keeping of the infectious material waste, no? We have two, and then immediately finish your work, you should do autoclaving. Okay? And then we have the inverted microscope and stereo microscope to observe the cells and also the CPE, cytopathic effect, after inoculation of the virus. Okay? When you inoculate the virus to the cell line, they will start to show the morphological change. Cell shape will change or sometimes detach. So that is a sign of the virus growth. Okay, so to observe daily base, we use the inverted microscope. Okay.
Okay.
I can go to the next room. So this one is a dangerous or toxic chemical storage cabinet. We are always looking this, okay, so that people will not accidentally access. Okay. Okay. And every year we report how much remain and how much we bought.
Mm.
Okay.
This is biosecurity.
Toxic chemical.
Toxic chemical.
P2 lab 1. Okay. And then the cluster A, they now in P2 lab 1, P2 lab 2, which is named open laboratory. Okay. So this one is usually for the parasitology group and protozoology group use. But now the Yamaguchi University team is temporarily using. Okay. So then the P2 Lab 2 is open laboratory. The reason why we named open lab is that like a pharmaceutical company sometimes request the long-term use of the laboratory for their the clinical research. So we used to use the same P2 laboratory with our research group, but they want to put their own machine, or they want to keep the clean space by themselves. So in case we have such kind of request in future, we will provide that one by with charging, so that we can have income and then we can provide the clean laboratory. And then also the end of that laboratory have an emergency exit. So in case the something fire or something happen at entrance that side, you cannot go out from that side. In that case, you can still go out from this side. Okay, so that you can safely evacuate. Okay, so just to check that how much for example, some compound give damage to the cells. How much cells alive, how much cells died. So like a safetyness of the compound we can check by NPTS. Okay. So in that case we use this much. And then also here we have the fluorescent microscope. So the detection of the virus or some microorganisms inside of the cells, or the presence of antibody. By using the immunofluorescent antibody technique, we can observe. Okay. So it used to be the fluorescent antibody techniques work inside of the dark room, wasn't it? But this one,
Very sensitive.
this box is the how to say dark room function. So the image of the cells is captured by the camera and then transferred to the computer, and then image will appear here. Then we will control the type of lens, and then the focus. We using the computer we adjust. So no need to work like this. Sorry? To use that? Sorry?
Can you use the bacilla?
Bacilla. Of course. Using the antibacillary fluorescent antibody. Yes. Not only virus, but also bacteria and also parasites, zoa, fungi, we can observe. Okay? Yes?
Can you explain what this is?
Okay. This one is a multifunctional plate reader.
Okay.
So the various wavelengths you can choose, and then no need to change the filter one by one. And then currently we are mainly used for the ELISA to read the absorbance of each well, but also my team member sometimes use the NTT assay with how many percent of the cells are still alive or dead or like that. So the many kind of purpose we can use this. So multifunctional plate reader. Okay. So this also we have the nanograph machine to make the DNA, RNA, and protein. We can using the 1 microliter or 2 microliter of sample. Okay. And then
Nanodrop?
nanodrop
machine?
Nanodrop one.
Yeah.
Okay. So if you use the ordinary spectrophotometer, you need like a 50 microliter or 100 microliter. Okay. Using this cuvette. Huh? But if you prefer if your sample is very small amount, then you just drop here 1 microliter or 2 microliter of your sample here, and then we apply like this, so that the result of the concentration of the DNA, RNA, or protein will appear.
No need any. Only this area sample?
Yes,
What area?
Yes, this tiny
Tiny.
dot.
Tiny
Yes.
dot?
So,
Sample area.
so you don't need to lose a lot of your precious sample, no? Because DNA, RNA sample is very small amount, right? Okay. And then they are doing the ELISA work using the plate reader and also the multifunctional plate reader. So we have incubator cabinet, but also the flow cytometer And also the chemiluminescence machine, and then the blood cell counter machine as well. Okay? So then that's the door emergency exit
Exit.
in case the fire happens, because most of the material is wood material, so we prepared for that. So the exit, and also yes. So in case we start the clinical research and then collect the like for the HIV, those one also we can do that. Not only CD4, CD8, but some other also. By staining the cells with a specific antibody, we can calculate the number of cells and how much before infection, after infection, then we can compare by checking the change of the graph image. Okay. Also the immunofluorescent antibody technique, but also we use the chemiluminescence, so chemical reaction. Using the chemical reaction, we will check that how much the antigen exists or how much the antibody exists. We can monitor it, and then this is more sensitive than other method. Okay. The refrigerated incubator means the ordinary incubator only the above the ambience, means above the room temperature you can control. But this one have a refrigeration function, so even setting of the temperature below room temperature we can set. Okay. So I don't know whether you know or not, but the incubator, any kind of incubator, you are required to have 5 degrees Celsius below the setting temperature. For example, if you culture 37 degrees Celsius for culturing the cells, no? Your room temperature should be 37 minus 5, means 32 degrees Celsius. 32 degrees Celsius is easy to maintain, no? But if your required condition is 28 degrees Celsius, like I showed you the one incubator for the arbovirus. The insect cell required to culture 28 degrees Celsius. So 28 degrees Celsius minus 5 degrees Celsius is how much?
23. 23.
Yes, 23 degrees Celsius, right? So in your country, sometimes above 23 degree, right? So in that case, like this, the refrigerated incubator can maintain below 33 or 33 at 23 or below 23, so that your cell can grow nicely. Okay. Okay. Right? So mainly for the recombinant DNA experiment. Okay. So using the E. coli, we put the plasmid, the protein expression plasmid, so that by culturing the checking the E. coli, we can grow the number of bacteria, and then by putting IPTG, they will start to express the protein, which is derived from virus. So there we can harvest and then purify the virus, how do you say, viral protein. So using the E. coli expression system. Okay, so it means you don't need to handle the large quantity of virus or bacteria. Okay, but you can safely produce the large amount of the viral protein. Okay, it's much safer, isn't it? No? For example, BSL-3 or BSL-4 pathogen, if you culture 1 liter, 2 liter, it's very dangerous, isn't it? But if you use the E. coli expression system, it has no infection ability, so then we can safely produce enough amount. Okay, so and then after culture it, we usually the centrifuge using this big the rotor and the bucket. Okay, each one can put around 500 ml. So means total 3 liter. We can centrifuge. After centrifuge, the equalize suspension, we suspend the precipitate of E. coli, and then we destroy using Sony paper. Okay? Then so that we can harvest the viral crop safely. Okay? And also we do the monoclonal antibody propagation. So same like the hybridoma cell, we do the culture, and then we precipitate, and then we purify using the protein G column, so that we can get the enough amount of monoclonal antibody. Okay, so that you don't need to use the laboratory animal. Only laboratory animal for the harvest, making the Sprinoside. And we inject the antigen to the mice, and then collect the spleen. And then we collect the sprinoside, and then we do the fusion, cell fusion with the myeloma cells, so that we can create the hybridoma cells. That's the start of the monoclonal antibody technique. Okay. Right. Okay. Let's go to your eye. You can immediately wash. Of course, you can wash hands or face here. Like that. We don't have shower. Maybe your institute have a shower. So our lab have not much space. That's why we have the sink and then eye wash. Okay. So this room, I think Betty already explained. But we have two capillary capillary sequencers, and then each machine have 8 capillaries. So 8 samples can be sequenced at one time. Okay, and then a 2 PCR workstation, and then one real-time PCR machine, and then for actually 5 conventional PCR thermal cyclers. Okay. So we are asking the users to record like this, so that how often the machines are used, and then any trouble, challenges encountered, they can write, so that we can quickly fix. Okay, like this. Not to find who broke. Maybe quickly
To troubleshoot.
Troubleshoot, yes. Okay. We never charge the user to fix. We do. So I think this is a global issue. But every single laboratory encounter that person who broke never report. Right? They just silently leave from
Because they fear charges.
then the next user find out. Oh, this machine not good, not functioning well. Then we don't know when it happened, who operated. So that's always the problem. That's why I always tell the users, we don't charge you, so please quickly report immediately, so that before it becomes a serious problem, we can quickly fix. If during the minor